From the tiny chip in your smartwatch to the massive servers that power the internet, computers are everywhere. But not all computers are the same. Today, we're breaking down every type of computer you need to know, from the smallest to the most powerful. Computers are everywhere, yet most people only know about PCs or laptops. In reality, computers come in various sizes and powers, from tiny embedded systems to gigantic supercomputers. Each type is designed for a specific purpose, balancing speed, memory, and functionality. Let's explore these types, starting with the smallest. Embedded computers. Embedded computers are tiny, specialized systems built into devices. Unlike your personal computer, they're designed to perform one specific task efficiently. Despite their small size, they have the essential components of any computer: a CPU, memory, and input-output interfaces, all condensed into a single chip or circuit. Examples of embedded computers are everywhere. Inside an ATM, the embedded system reads your card, communicates with the bank, and dispenses cash. In a smartwatch, it tracks steps, measures heart rate, and syncs with your phone. Even smart TVs rely on embedded computers to run operating systems, launch apps like YouTube or Netflix, and manage streaming. The key advantage of embedded systems is efficiency and cost. Because they're built for a single purpose, they're far less powerful than a PC, but extremely cheap to manufacture and reliable. This allows companies to mass-produce them for countless devices in our daily lives. Personal computers. A personal computer, or PC, is the type of computer most people know and use every day, including laptops, desktops, and tablets. Unlike embedded systems, PCs are designed for one person at a time and can handle a wide variety of tasks, from browsing the web and playing games to writing documents or creating content. The story of PCs begins with microcomputers. Before the invention of the microprocessor, computers were massive machines that took up entire rooms. The microprocessor changed everything by allowing a complete computer to be built on a single chip, making it compact enough to fit on a desk or in a home. A PC is made up of several essential components that work together. The CPU, or central processing unit, acts as the brain, processing instructions and running programs. RAM provides temporary memory to keep tasks running smoothly, while storage drives like hard disks or SSDs hold your files and applications. Graphics cards handle visuals for videos, games, and design, and the motherboard connects all these components into a functioning system. PCs are flexible and upgradable. You can add more RAM, swap storage, or upgrade the graphics card. Whether for home use, office work, or creative projects like video editing and design, PCs provide moderate power at an affordable cost, making them perfect for everyday computing. Minicomputers. Minicomputers, also known as mid-range computers, fill the gap between personal computers and mainframes. Unlike a PC, which is meant for one user, a minicomputer can support hundreds, sometimes even thousands of users simultaneously. This made them ideal for universities, hospitals, and medium-sized companies, where multiple people need to access data or run applications at the same time. A key aspect of minicomputers is that they're designed for continuous operation. They can run 24/7 without shutting down, making them reliable for critical tasks. These computers are also much more powerful than a typical PC. While a home computer might have 8 or 16 gigabytes of RAM and a few terabytes of storage, a minicomputer can have tens or hundreds of gigabytes of RAM and terabytes of storage. They also often have multiple processors, allowing them to handle heavy workloads, like managing databases or running enterprise applications. Even though they're called mid-range, it doesn't mean they're mediocre. In fact, they can outperform high-end PCs in terms of multitasking and processing power. Mainframes. Moving up the scale, we encounter mainframes, which are essentially the giants of the computing world. If minicomputers can be compared to busy office buildings, mainframes are like entire cities of computing power. They're built to handle massive amounts of data and complex operations for large organizations, often at a national or global scale. Banks, Airlines and government agencies rely on mainframes to process millions of transactions every second, manage flight schedules worldwide, or store citizen records. What makes mainframes so powerful is their hardware design. They contain hundreds of processors and vast amounts of RAM and storage. While a minicomputer might have a few terabytes of storage, a mainframe can have petabytes of data storage. They're designed for fault tolerance and high availability, meaning even if one part fails, the system continues running without interruptions. This reliability is why mainframes remain the backbone of industries that cannot afford downtime. Mainframes are not only powerful, but also expensive. They require specialized maintenance, climate-controlled environments, and highly trained staff to operate. Despite these costs, they're indispensable for institutions that process vast quantities of data every day. Unlike PCs or minicomputers, mainframes aren't meant for personal use. Instead, they exist to serve thousands of users simultaneously while performing mission-critical tasks with absolute precision. Supercomputers. At the very top of the computing world are supercomputers, the giants designed for tasks that no other computer can handle. Unlike PCs or even mainframes, supercomputers aren't meant for everyday work or business operations. They exist to solve problems that require extreme speed, massive processing power, and enormous memory. Think of analyzing climate change models, simulating nuclear reactions, mapping the human genome, or exploring the far reaches of space. These are the machines that tackle problems that would take a regular computer years to solve in just hours or minutes. Supercomputers achieve this through thousands of interconnected processors working together. They're capable of performing trillions of calculations every second, far beyond the capacity of any mainframe or personal computer. With such intense performance comes extreme heat, which is why supercomputers require special cooling systems, often using chilled water pipes or liquid immersion technology. They're also incredibly expensive, costing millions to build and operate, which is why only governments, research institutions, and large global organizations own them. While embedded computers handle a single task, PCs serve individuals, minicomputers manage hundreds of users, mainframes support organizations on a global scale, supercomputers are in a league of their own. They are the pioneers of scientific research, the engines behind breakthroughs in technology, and the tools that allow humanity to understand complex phenomena in ways that were unimaginable just a few decades ago. In conclusion, computers come in many forms, each designed for a specific purpose. From the tiny embedded computers in our devices to the colossal supercomputers exploring the universe, each type plays a critical role in modern life. Understanding these differences not only helps us appreciate the technology we use every day, but also shows us how far computing has come and where it might take us in the future.